This lesson will cover permutation and combination. We will talk about how to recognize and distinguish between a permutation case and a combination case, as well as answer simple problems on arrangement and selection. Cases with repetition of objects or with objects arranged in a circle or involving both permutation and combination are excluded. First, a permutation is an arrangement of items in a particular order, which means if we have a group of letters, for example A, B, and C, arranging the letters in the form of ABC and in the form of ACB count as two separate arrangements. A question may be, if we have letters A, B, C, D, and E, we have to use those letters to arrange into a new three-letter word. To think about this problem, imagine that there are three blanks. Think about the possibility of letters in the first blank, possibility of letters in the second blank, and the possibility of letters in the third blank. For the first blank, there are 5 letters, so there are 5 possibilities. For the second blank, there can only be 4 letters because one of the letters is used up in the first blank, so there are 4 possibilities. And for the final blank, there are only 3 letters because 2 letters is used up in the previous blanks. And according to the product rule, the total possibilities should be 5 times 4 times 3. And this brings us to the general formula of permutation. NPR, where P represents permutation, gives you the equation n factorial over n minus r factorial, where 0 is smaller or equals to r, and r is smaller or equals to n. In the case of the last question, we can use permutation to solve it, as 5 represented by the total number of things in the group, and 3 by the number of picks or the amount of item in the arrangement. So 5p3 equals 5 factorial over 5 minus 3 factorial, which gives you 60. Let's try a practice question. A combination lock will open when the right choice of 3 numbers from 1 to 30 inclusive is selected. How many different lock combinations are possible, assuming no numbers is repeated? First, this question involves permutation because orders do matter. There's a difference from 1, 2, and 3, and 2, 2, 3, and 1 in a number lock. So we know the number in our group is 30, and we know the numbers in the arrangement is 3. So we just plug in the numbers 30p3, and we'll get 30 factorial over 30 minus 3 factorial, which will give us 24,360. Another problem. From a club of 24 members, a president, vice president, secretary, treasurer, and historian are to be elected. In how many ways can the office be filled? This is again a permutation problem, since the order do matter. There's a group of 24 people, and we have to make them into groups of 5. Therefore, we do 24 permutation 5, and will give us this result. Now, on to combination. A combination is an arrangement of items that is not in any order, which means in the case of arranging letters A, B, and C, A, B, C, and ACB will count as one arrangement. Here's the general formula of combination. N factorial over R factorial times N minus R factorial. Question. To play a particular card game, each player is dealt 5 cards from a standard deck of 52 cards. How many different hands are possible? This is not a permutation problem, since the arrangement of those 5 cards in your hand doesn't matter. It doesn't matter if it is 1, 2, 3, 4, 5, or 1, 2, 5, 4, 3. So we'll use combination. Since there are 52 cards in the deck, and we're trying to find groups of 3, so we'll do 52 combination 5, which will give us this result. Here's another question. A student must answer 3 out of 5 essay questions on a test. In how many different ways can the student select the questions? This is again a combination problem instead of a permutation problem, since the order of those essays doesn't matter. Out of total 5 essays, we're making groups of 3. Therefore, we do 5 combination 3, which will give us 10. Finally, here's a recap of the whole lesson. Permutation is where the order of the arrangement matters, and combination is when the order of the arrangement doesn't matter. Thank you.